This is section 5.4, properties of logarithmic functions. The first property that we're going to look at is the product rule. Product rule looks something like this. You have a log of any base, and you have some value m times some value n. And these can be numbers, letters, or expressions. You can separate this into two logarithms of base b of m plus log base b of n. Now this is very helpful that you know that the log can be of any base. So as an example, we could have log base 3 of 2x times x minus 2. And we can separate this into log base 3 of 2x plus log base 3 of x minus 2. Anytime you have multiplication here, it turns it into addition. Now, this rule stems from the fact that if I had two things being multiplied together, like x to the 5th times x to the 6th, we know that we would add our exponents together. And so the logarithm is really just an expression of exponents, and that's why this rule works. The next rule is called the power rule. And the power rule says that if you have a log of any base and you have your argument is m, and then you have some power, we'll call it p, we can change that into p times that log base b of m. So it has the effect of bringing the exponent down front, and you rewrite it like this. So an example of that would be log base 5 of x squared. You can change that to 2 times log base 5 of x. And then lastly, we have the quotient rule. In the quotient rule, you have the argument in the log, two numbers that are being divided by each other. This becomes the log of the first one minus the log of the denominator n. Subtraction here, because remember that if you had 1 over x, you could write that x to the minus 1. And so that's why this one works, is because we have this negative exponent, as you could think of as n to the negative 1, and you have a plus sign here. And so it's just like the product rule, except it's a negative sign here because we have a negative exponent rule. An example of this would be if we had log base b of 2x over x minus 2. We can change that into log base b of 2x minus log base b of x minus 2. Okay, so those are the three rules that are in this section. The idea is to actually just put them all together. Let's say I had an example like this, where I had log base 5 of x squared y cubed over z to the 5th. You can take one step by separating them by using the product rule and the quotient rule, and we can do log base 5 of x squared plus log base 5 of y cubed minus log base 5 of z to the 5th. Anything that's going to be in your denominator is going to have a negative sign in front of it. Anything that's going to be in your numerator is going to have a plus sign in it. And then we can change using the power rule, and we can bring our exponents down front. And that's it. We can also do these rules, log base a of a to the x, and we can say that that's just equal to x. And the reason why it's just equal to x, because we can use our power rule where we bring x down front, and we ask ourselves, what power of a gives me a? Well, a to the first power is equal to a, so this actually has a value that's equal to 1, and that's just going to be x. And we also have this one here, where we have a of log base b of x is also equal to x. Now this one's a little bit different. The way that we show this is that we change it into exponential form. And so this becomes log base b of x, excuse me, this is a, log base a of x, which is this part here, that's the exponent, and then we change that into log base a of x. We're actually changing it to logarithmic form. This is exponential form here. We're changing it to logarithmic form here. Just as if I had 3x is equal to y, that is log base 3 of y equals x. I would change this into log base a of x, which is my exponent, and that equals my base here and this here, so that's log base a of x. Now, with these properties, you can solve all kinds of problems. Let's say I had something really complicated like log base c of the cube root of y cubed z squared all over x to the fourth. The first thing that I would do is take care of this root part and understand that I have log base c, and that's y cubed z squared x to the fourth, and that's all to the 1/3 power. I would use my power property to bring this 1/3 down front. And so now I have 1/3 log base c of y cubed z squared and then x to the fourth. Now I can separate this into 3 different logs using these here. I'm going to leave the 1/3 out front, put a big bracket here. I'm going to get log base c of y cubed plus log base c of z squared minus log base c of x to the fourth. And now I can bring my powers down front. This is still going to be 1/3 log base c, I'm sorry, I'm going to bring my 3 down front here, of y, plus 2 log base c of z minus 4 log base c of x. And then I can multiply my 1/3 here, here, and here. 1/3 times 3 is 1. That's just going to be log base c of y plus 2/3 log base c of z minus 4/3 log base c of x. You can get to this part, you're doing pretty good. That's about as hard as these get. All right, good luck. That's all of section 5.4.